With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, today we are going to solve this question. The question says that a closed coil having 100 turns is rotated in a uniform magnetic field B equals to 4 into 10 raised to power minus 4 Tesla about a diameter which is perpendicular to the field. The angular velocity of rotation is 300 revolutions per minute. The area of the coil is 25 centimeter square and its resistance is 4 ohm. Find the average EMF developed in the half a turn from a position where the coil is perpendicular to the magnetic field. B, the average EMF in a full turn, and C, the net charge displaced in part A. So this question has various parts, so we can look at what all things are given to us for easier transaction. Number of turns are given to us, so that is N, 100 number of turns. Then we have the magnetic field, so B is given as 4 into 10 raised to power minus 4 Tesla. Then we have the area that is given to us, but it isn't centimeter square, so we are going to convert it into meter square. So it's going to be 25 into 10 raised to power minus 4 meter square. Other thing that we are given is angular velocity, or omega. We can write it as it is 300 revolutions per minute. All of these things are given to us in the question. To solve the question for A part, we need to calculate the average EMF. Average EMF is calculated by calculating the flux, then we calculate E. So for d phi, basically EMF equals to minus d phi by dt. And for that, d phi is equal to phi 2 minus phi 1, the change. And for that, phi is equivalent to, in this case, number of turns are also calculated. So it's going to be N B A. B and A are in dot product. So we are going to calculate it for this case. In the first case, it is perpendicular, and then we are going to change the angle. It's going to be at a different angle because it's turning with a angular velocity. So when we take the first case, phi is going to be equivalent to NBA because theta is equivalent to 0 degree. So it's going to be our phi 1. But in the other case, when coil is rotated, in this case, our phi is going to be, phi 2 is going to be NBA cos 180 degree because theta is rotated at 180 degree. In this case, it is completely rotated. So cos 180 degree is minus 1. So the value is going to be equivalent to phi 2 is minus NBA. They have phi 1 and phi 2. So we can find d phi basically. So d phi for this case is going to be phi 2 minus phi 1 as the formula says, and the value is going to be equivalent to minus minus of both, so it's going to be 2NPA minus 2NPA. This is the value of d phi that we have. Other than that, in the question, it is also given that there is an angular velocity, but it is given in revolution per minute. To solve it, to use it in our question, we need to convert it. So it is given as 300 revs per minute. We need to convert it into radian per minute. So for that, we have to change it, and we can do that by only doing it as 300 into 300 into 2 pi. That will give us as radian per minute. We can change it into radian per second as well. So we can simply divide it by 60. So it's going to be 300 into 2 pi upon 60 will give it as radian per second. So the value is going to be equivalent to 10 pi radian per second. So the rotation that it takes place, it's going to be this. But when we calculate it for 1 pi radian rotation, how much time does it take? So when we consider that for 1 pi, time taken by unitary method is going to be equivalent to 1 pi divided by 10 pi, which is going to give us basically 0.1 second or 1 by 10 second. This is the difference of time that we are going to get. This is the time we need to use for dt. So dt is going to be equal to 0.1 second. We have both the values. To calculate the value of E, we can simply put them in. So E is going to be minus d phi by dt, and the values are minus of minus 2 NBA upon dt is 0.1, and those are going to be 2 into 100 turns into 4 into 10 raised to power minus 4 Tesla into the area, which is 25 into 10 raised to power minus 4 meter square upon 0.1. So the EMF induced is going to be equivalent to 2 into 10 raised to power minus 3 volts. This is what was asked for part A. Now for our other parts, we have to calculate it for when the So for the B part, it is asking for the EMF for the complete circle. So theta is, when we are starting with the rotation, it's going to be equivalent to 360 degrees. So when we take this as the value, for first case, phi is going to be NBA, just like in the first part. But for the second case, phi 2, the case, it's going to be NBA cos 360 degrees. And cos 360 value is 0. So phi is going to be 0. Phi is going to be, d phi is going to be 0 because phi 2 is going to be NBA. So d phi is going to be 0. So our EMF E, which we need to calculate, is going to be 0. There is no use of calculating. Our value for B value for the B part is going to be 0. A C part is asking for the current. In the case, basically they are asking for the charge, and charge can be only calculated when we first calculate our current. So for C part, I equals to current equals to E by R, and we have calculated both the values. One is given to us, the resistance, and E we have calculated right now. So we'll simply put them in the question. So it's going to be equivalent to 2 into 10 raised to power minus 3 upon 4, because it is 4 ohm. So the value is going to be 1 by 2 into 10 raised to power minus 3 ampere. Now we need to calculate the charge which is asked in the question. Q is I into dt. So we have both the values here as well. So it's going to be 1 by 2 into 10 raised to power minus 3 into 1 by 10. And for the solving, the value of Q that we are going to get as our C part answer is going to be equivalent to 5 into 10 raised to power minus 5 coulomb. This is going to be our final answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.